Here we have then the axial forces produced across all members, along with those corresponding to the values at the extremes. And where is that these are located in the structure? Again, these results correspond to the currently selected case or combination. Thus, we can always go back to the case list and check the results for different loads. Just don't forget to click on the Normalize button as you go through these cases, since this will automatically adjust the scale of the diagrams. So, it is in this way that we can begin to check the behavior of our model and perhaps make some decisions design-wise. Let's return, for example, to the Internal Forces tab. And this time, let's check the diagram and resultant values for the ensuing shear forces. Now at this point, something worth mentioning is that although Robot is providing us with these results, it's not telling us whether or not these are ideal or if they comply with any specific design code. For instance, thus far, we don't know for sure if these forces are producing excessive buckling that may compromise the integrity of any of these columns, or if this buckling is within the design code parameters. So for finding that out, we would need to perform an analysis of the steel sections. Then, up to this point, we may say that these results are to be used at your discretion. However, they do provide enough information so we can begin to consider some design adjustments in our model. But let's continue verifying additional results and take a look at the reactions on the supports. Although first, let's not forget to clear the current diagrams. So here we have the reactions at the supports expressed in kilonewtons along with the maximum and minimum values. Or, given the currently active case, what we may also describe as the forces acting on the supports due to the self-weight of the structure. As you can see then, making use of the diagrams panel is relatively easy, and the results shown are also easy to understand. Finally, let's take a look at the deformation diagrams. Once again, let's not forget to clear the current results. So this brief animation, albeit somehow exaggerated due to the current scale, clearly shows us the type of deformations that this frame will experience under the design loads. Now to continue with the development of this model, and as we said earlier, the next step is to check the integrity of the steel members. Since this will help us to better understand if this current design is viable and compliant with the governing design code,